Hey guys, welcome back to my YouTube channel. In this video, we'll be looking at continue our video series on percentage error, and we'll be solving other possible questions, other percentage error in this video. So in this video, we look at calculation based errors. We're looking for two examples basically. So in the first question says is class is actually 10 millimeter by 10 meter, but a student measured each side to be 9.5 millimeter. I don't know how that was possible, but that was the question. So find the percent error in the length of one side and also the area of the room. So we have to go straight into the question. So taking also the first one at a side of the length of one side in this side since they're equal. So they are of equal length. So the true length is in this regard is the true length is actually 10 meter, but the student measured length is 9.5 meter. The error in length now is error like now established in our previous video is the absolute of our measured minus true value. So our measured is 1.9.5 over 10. So it's the absolute. Absolute is whatever your answer is to be absolute, that has to be positive. So our answer here is going to be 0.5 meter. So we've gotten in there. So the percentage error now, formula for our percentage error is error as gotten here over the true value times 100. So how this is going to be used. So error is 0.5 over other 10 times 100. So this is what we got to is bringing this cancel. So these are 5%. So that's just for the length of the side. But the second question says when the area of the room was found. So when we calculated the area of the room, so we have to actually calculate the true area of the room in this regard. True area of the room. This is true one. True. That would be 10 times 10. Because that's area. That's like a square. That's 10 square. And the room is the is square. So the measured one you calculate using the measured length, measured area. That way, that be 9.5 times 9.5. So I prefer putting this in your calculator. I have 2.5 meter square. Right. So now the error as established area measured minus the true area. So absolute, the absolute that will be 90.25 meter square minus 100 meter square. So this is also the error of the absolute. So whatever we get since it's absolute will be positive. Whatever we get since it's absolute will be positive. So our answer here is 9.75 meter square. Right. So we have this. So we go on our percentage error, which is the error of 9.75 over the actual one times 100. The answer is basically just straight this as 9.75%. The only difference is that since this was multiplied, that's why this actually increased. The percentage was increased, so multiplied. So now next question, we're looking at another question. Look at another question which says a student measures the radius of a circle as 1.46 centimeter instead of 1.38 centimeter. Find the percentage error in the circumference and the area. So that means we have to find the circumference and the area. The first, what was our true radius in the first instance? true radius is, say, true radius is, say, the first one we have to find in circumference. Our true radius is, instead of 3 centimeter, but the measured is 1.46 centimeter. Then to look for the circumference now, the true circumference will be using the formula of the true circumference, that will be 2 pi r. That's our radius. 8 centimeter. You put this into your calculator, be having roughly 8.67 centimeter, right? So while the measured circumference, let's put it as cm, as 2 pi down times 1.46, that will be giving us an 9.17 when we put in our calculator. So in order to get our error now for circumference, error for the circumference, let me just put circumference. So no, so you can just do as the cm as established in the previous one, absolute of the cm measured circumference minus the ct here. So the ct, so that will be 8.67, sorry, 1.7 centimeter minus 8.67 centimeter absolute. So give us the final answer to be 0.5 centimeter. Then our percentage error, as the subject as I showed earlier, so percentage will be the error 5 over the true value. What's our true circumference now? Is what to be using our true circumference. Let's take into that 8.6. So we just the true value times 100. So that will be giving us a 5.8 percentage when we put it to one decimal place. Then to the second one, we are asked to find the percentage error in the area. So we also have to look for the true area, and let's just say as 80. So that will be pi r square. So that will be pi. What about true radius? 1.38 square. That will give us a. You put this into our calculator, we have 5.98 centimeter square. Then the measured area due to the wrong radius, pm, will be pi. This we can have 1.46 square, and if we put this into our calculator, we'll be having 6.69 since the radius is larger. So now to get our measured now, our error, the absolute of the measured area, am, minus the absolute minus the 8, that is the true. So when you do this, you have 6.69 minus 1.46, right out. So when you subtract this, we're having 0.71 meter square. Sorry, centimeter square. So you can find out percentage error is equal to 0.71 over what's our true error area. Please just take with that. That's where most of my students mix it up. So you have this times 100. So when you put this into your calculator, you should be having 11.98 percentage So this is possible questions of percentage error involved in calculations. So in my next video, I'll give you a bonus possible questions we can see in our questions. See you in the next video. Thank you very much.